I've been able to see how the technical work that I'm doing is going to directly impact policy being made today and in the future. As we introduce more time-dependent renewables, so that's solar, hydro, wind, into our grid generation, it becomes increasingly important for planners to have as much temporal, granular data as they can to build the optimal grid, essentially. Better energy grid design methods will make generating grid designs with high-resolution data more scalable. As planners and governments get access to this new technology and these new methods, it becomes easier for them to be more agile in how they're generating grid designs. This means that in historically underserved communities with developing grids, they are able to test and retest their models more frequently, and I think this kind of government engineering intersection is just something that's going to be increasingly important in coming years. In cases where you're experiencing these extreme weather events, it becomes increasingly important to include as much temporal data as you can, such that your energy grid design is going to be able to fare well when inevitably extreme weather events happen again in the future. When vulnerable communities get hit by these kind of extreme weather events where their energy grids are being maxed out, they suffer the most. Because climate change is as much an engineering issue as it is a social justice issue.